Hello guys, I am Flash Isaac. Today I shall be taking you through hydrocarbons. I promise to make this class as interesting as possible and as detailed as possible. Let me begin this way. Organic chemistry is the study of carbon and its compound, except the carbides of carbon, the sulfides of carbon, the oxides of carbon, and the carbonates of carbon. Carbides are usually formed when carbon reacts with metals. Sulfides, carbon and sulfur. Oxides, carbon and oxygen only, e.g. carbon 4 oxide. And carbonates, example CaCO3, that's triazocarbonate. So the study of carbon and its compound, except for these guys, carbides, sulfides, oxides, and carbonates, is referred to as organic chemistry. Now, organic chemistry is divided into hydrocarbons and non-hydrocarbons. Hydrocarbons are compounds formed or compounds that contain carbon and hydrogen only. So when you see a compound and it is made up of carbon and hydrogen alone, it is referred to as hydrocarbon. For example, you see this structure here, hydrogen, carbon, carbon, hydrogen, no other element. This is referred to as hydrocarbon. Meanwhile, if you are given this, and let's say chlorine here, this is no longer hydrocarbon because this compound is formed by carbon, hydrogen, and chlorine. So carbon, hydrogen, and other elements. Or if you have, let's say OH here, it is no longer hydrocarbon because other elements have been introduced. Now that you understand hydrocarbon, hydrocarbon is divided into aliphatic hydrocarbon and aromatic hydrocarbon. Aliphatic hydrocarbon is simply hydrocarbon that is made up of normal straight chain or branch chain. It can also be cyclic. That is aliphatic hydrocarbon. Meanwhile, aromatic hydrocarbon is a hydrocarbon that contains benzene ring. Benzene and its hydrocarbon and its derivative like xylene and toluene. Now, benzene is an aromatic compound, first because of its sweet smell. Two, because of its alternating double bond. So benzene is a hydrocarbon which is made up of alternating double bond. And the formula for benzene is C6H6. What does it mean? C6 means we have 6 carbon, H6 means we have 6 hydrogen. Now you see they are arranged in a ring 1, 2, 3, 4, 5, 6. And look at something else about benzene. You notice the alternating double bond. 1 here, dot, 1 here, 2, 1 here, 2. This is benzene ring. And any organic compound or any hydrocarbon that contains the benzene ring is referred to as aromatic hydrocarbon. Now, aliphatic hydrocarbons can be cyclic or acyclic. Cyclic means it has a cycle, it's in form of a circle, not benzene ring, but in form of a circle. For example, you see this 1, 2, 3, the 3 carbons, they are in a circle, almost in circular form, not straight form like you see here. So in this case, we say it is cyclic. And what is this compound called? It is called cyclopropane. Why propane? 3 carbon, 1, 2, 3. So one is this contains 1 carbon, it is meat. 2 carbon, earth. 3 prop. 4 carbons, boots. So if it were 4 carbon, it would be butene. 5 carbon, paint. 6 carbon, hairs. 7 herbs. 8 oct. 9 non, and 10 deca. Look at something else. It contains 3 carbons in cyclic form, and you see other elements are hydrogen. So carbon and hydrogen alone. So this is cyclic hydrocarbon. So example, cyclopropane. This is propane, but in cyclic form. Look at propane that is not in cyclic form. Propane means 3 carbon. So if you have something like this, 1, 2, 3, and A means alkane, single bond throughout. So every other thing is hydrogen. So this is propane, while this is cyclic propane. This is acyclic and this is cyclic. So the three common acyclic hydrocarbons are alkanes, alkenes, and alkynes. So example of an alkane is methane. Why methane? Methane has one carbon and it has single bond throughout. So you see one carbon, single bond. Alkenes, they have double bond, two bonds, carbon. Ethane, it has triple bond, 1, 2, 3. Now, the study of alkanes, alkenes, and alkynes is very interesting. There are a lot of things you need to learn. This is why the next thing you shall be learning right now under hydrocarbon is the comparison of alkanes, alkenes, and alkynes. So take a look at that. Let us compare alkanes, alkenes, and alkynes. First of all, let's look at some physical properties. For example, alkanes are colorless. Alkenes are colorless. Alkynes are colorless. Alkanes are less dense than air. Alkenes are less dense than air. And alkynes are less dense than air. Alkanes have no effect on litmus. Alkenes have no effect on litmus paper. And alkynes have no effect on litmus. Now, alkanes are odorless. Alkenes are sweet. And alkynes have garlic smell. While dealing with alkanes, alkenes, and alkynes, take note of something. Here, ANE, here, ENE, and here, YNE. That is what makes the difference. And take note, they are aliphatic hydrocarbons and they are acyclic. The first thing here is general formula. Alkanes, alkenes, and alkynes, they all have general formulas. The general formula for alkanes is simply CnH2n plus 2. CnH2n plus 2. Let me write here. What does this mean? If I say an alkane has 3 carbons, find the formula of that alkane, ANE. What do? You simply come here and say that since it has 3 carbons, here is C3 because N is the number of carbons. H2N simply means H2 times 3, which is the number of carbons, plus 2. So, plus 2. This is simply C3. 2 times 3 is 6, plus 2, 8. So, H8. So, the formula for an alkane with 3 carbons is simply C3H8. Now, what if it were to be an alkene? The formula for alkene is CnH2n. So, therefore, it will simply be CnH2n, no plus 2, meaning here will be 6. That is it. What if you were to draw C3H6 or for the first one C3H8? Alkanes have single bonds. You simply say, okay, C3, 3 carbons. 1, 2, 2, 3. 3 carbons. Then every other thing, hydrogen. Now, while adding hydrogen, take note of something. Carbons are tetravalent, meaning they can carry maximum of 3 or 4 bonds. 4 bonds tetravalent. So you count how many here? 1, 2, 3, 4. It is complete. 1, 2, 3, 4. It is complete. Now, what about a situation where there is double bond here? If there is a double bond here, it means we can no longer have 3 hydrogen. We need to remove 1. So removing this becomes 1, 2, 3, 4. Complete. Here, 1, 2, 3, 4, 5. We also remove 1. In that case, this is correct, giving us 1, 2, 3, C3, 1, 2, 3, 4, 5, 6, H6, giving us alkene and double bond. While alkyne will simply be CnH2n minus 2, meaning anything you have in alkene remove 2, which is C3H6 minus 2. That is C3H4. That is it for general formula. Now, the first member of alkanes is methane, CH4, 1 carbon, 4 hydrogen. And it is like this, 1 carbon, 4 hydrogen. The second member is ethane, ETHANE, ethane. What would that be? 2 carbon, you add hydrogen. Using this formula, 2 carbon, 2 times 2, 4, plus 2, 6. That is C2H6 is the second member. So this is very important. They can give you different formulas. Let's say C3H6, C2H6, C3H8, and they ask you, which of the following is an alkane? What you simply do is, bring out the general formula and substitute the number of carbon. Anyone that gives you a particular number for this formula is an alkane, alkene, or alkyne, depending on the question. So this is a hot cake question. Now look at this. The first member here is ethane, ethene. This is because alkenes have double bond. So if you have just 1 carbon, there's no way you can have that double bond to hydrogen. So the simplest member is ethene, ETHENE. So 2 carbon, 1, 2, 3, 4, 4 hydrogen, following the formula C2, 2 times 2, 4. And the fourth member here is ethyne. It has triple bond. Ethyne will simply be C2, 2 times 2, 4, minus 2, 2. So this is C2H2. This is the formula for ethyne. So triple bond. And remember, carbon can carry 4 bonds. 1, 2, 3, 4, complete. 1, 2, 3, 4, complete. So that is it for that. And under hybridization, if you follow my video on orbitals, I explained hydrocarbon and I explained hybridization. So alkanes are sp3 hybridized, alkenes are sp2 hybridized, and alkynes are sp hybridized. So questions under here is simply, what is the hybridization of this, that? So you don't need to go deep. If you know this is sp3, this is sp2, and this is sp, then you are good to go. Bonds. Alkanes have single bond, as you've seen in my explanation. Single carbon to carbon bond. Alkenes have double carbon to carbon bonds, and alkynes have triple carbon to carbon bonds. Now, the bonds in alkenes are sigma bond. Sigma bond has to do with orbital overlapping of orbitals. So when there is head-to-head overlapping of orbitals, you form sigma bond. Sigma bond. So alkenes have 1 sigma bond. Alkenes have 1 sigma bond and 1 pi bond. Pi bonds are formed by side-by-side overlapping of 2p orbitals. And alkynes form 1 sigma bond and 2 pi bonds. Take note of that. Under degree of saturation, alkanes are saturated, meaning they have what is enough for them. Single bond throughout, so it's complete. But alkenes and alkynes are unsaturated, meaning they have double bonds that can be broken down to give us more hydrogen. So unsaturated, unsaturation. Then, how do we prepare alkanes in the lab? The preparation of alkanes involves reaction of soda lime with soda ethanoate. Soda lime is simply sodium hydroxide. So when sodium hydroxide reacts with sodium ethanoate, CH3COONA, it forms sodium carbonate, Na2CO3 plus CH4. And CH4 is the first member of alkane, which is methane. And the reactions of, we will get there. To form alkenes, it is simply dehydration of ethanol using excess H2SO4 at 170 degrees. There is a big difference between drying and dehydration. Drying is the removal of water. Meanwhile, dehydration is the removal of elements that make up water. For example, C2H5OH, it doesn't contain water, there is no H2O. But we dehydrate it, it has the elements of water, hydrogen and oxygen. So when you dehydrate it in the presence of concentrated hydrogen tetrasulfate 6 acid, you form C2H4, which is the first member of alkenes. And aqueous in formula simply means in solution. So solution of a compound. Meanwhile, alkynes are formed by action of cold water on calcium carbide. Calcium carbide, carbide of carbon, water liquid. So they form the first member C2H2. And the chemical properties. Alkanes undergo combustion reaction. They all undergo combustion reaction. Combustion simply means to burn. So after this, I will take you through the uses of alkanes, alkenes, and alkynes. Then I will just drop the general formula for combustion of these hydrocarbons. Substitution reaction. Alkanes undergo substitution reaction. Example, chlorination. If you are given this, you notice that the bonds are already complete. So you can't add any other thing. But you can substitute, meaning to replace. So when you remove this, you substitute it with, let's say, chlorine or something. This is chlorination. You've added chlorine. You substituted. But if it were to be alkene, something like this, you can break one bond and add instead of substituting the ones that are already there. So that is what we refer to as substitution reaction. Because of the saturation and the presence of only single bonds, alkanes cannot undergo addition reaction. They can only undergo substitution and combustion. Meanwhile, alkenes can undergo combustion, addition, and polymerization. Polymerization is a phenomenon in organic chemistry or hydrocarbons where smaller molecules, monomers, they combine to form a bigger compound, which are called polymers. Alkanes and alkynes, they undergo similar reaction: combustion, addition, and polymerization. So let's see the uses and other things you need to know. Alkanes are also called paraffins. Alkenes are also called olefins, and alkynes are also called acetylenes. And the natural sources of hydrocarbon are coal, natural gas, and petroleum. These are the natural sources of hydrocarbon: coal, natural gas, and petroleum. The uses of alkanes: 1. Domestic and industrial fuel or fuel. 2. They are used to make important organic compounds such as carbon black, chloroform, which is an anesthetic, and tetrachloromethane, which is used as solvent in detergents. Alkenes are used to make polymers like polythenes. You see, they are products of alkenes. And alkenes can be used to hasten fruit ripening, and they are used in petrol additive, which has 1,2-dibromoethane. Alkynes are used in miners' lamp, and they are mixed with oxygen to form oxyethyl flame for welding and cutting metals. They are also used for PVC, polyvinyl chloride. Remember, we said hydrocarbons are aliphatic or aromatic. So we've been talking about aliphatic since. We also mentioned benzene and benzene ring, some properties of benzene. For example, benzene is colorless, which is here. Benzene has sweet smell. Benzene is sp2 hybridized, and benzene undergoes addition reaction. And benzene is so stable that it takes time for you to break that bond. It is very, very, very hard. And it prefers that for an nesting to substitution, at least to still maintain the benzene ring. Look at this. How do we produce benzene? To produce benzene, you pass ethane through red-hot tube containing a complex organonickel catalyst. So passing ethane C2H2 through red-hot tube containing complex organonickel catalyst, you form benzene. So this is preparation of benzene. And look at something. The most acceptable formula or the structure for benzene was proposed by August Kekule in 1865. He proposed the structure of benzene. And according to him, benzene has two identical forms. And that is what we call resonance. When a compound has two identical forms or structure. For example, look at this. This is C6H6, right? And remember, benzene has alternating double bond. So look at here. The double bond starts from here, single bond, double bond, single bond, double bond, single bond. Now look at another form. Another form might be it starts with single bond instead of double bond. Then next double bond instead of single bond. Then next single bond instead of double bond. Like that. So alternating form, it goes here and here. In that case, we say benzene maintains resonance. So this is the resonant form. So look at it. This can also be represented this way. Alternating double bond. This one starts from here, this one starts from the second one. So this and this are the same. When represented in this form, you observe what is happening. Once they combine in that resonance form, it becomes a circle. So this is benzene in resonance, alternating double bond. Having said that, benzene have derivatives of benzene, and that will also take us to uses of benzene. This is benzene itself. By the time you add OH here, you form phenol. And what is phenol? Phenol is used as disinfectant. So this is one derivative of benzene. How about you add CH3? You form toluene, and toluene is used as explosives. That is toluene. How about you add NH3 here? You form aniline. And when you join two benzene together, you form naphthalene. These are benzene derivatives. Once you have something like this, CH3, or any other one here, CH3, it forms xylene. And benzene is also used as detergent. Then aniline is used in making drugs. So the formula for combustion of hydrocarbon is simply CSHY plus S plus Y over 4 O2 to give us SCO2 plus Y over 2 H2O. The result of combustion of hydrocarbon is simply carbon dioxide and water. Now look at this. S simply means the number of carbon, Y means the number of hydrogen. So S here is the number of carbon, number of hydrogen. So when you add these two, it will give you the number of oxygen. And S here is the number of carbon, Y over 2 water, number of hydrogen divided by 2. So just write down this formula. So this is the practical usage. Once you are given C2H6 and you are asked to derive the formula for its combustion, you simply look at this. S is 2, right? And Y is 6. So you say C2H6 plus, instead of S, 2, which is number of carbon. Instead of Y, 6, number of hydrogen. So 6 over 4, oxygen, O2. To give us, instead of S, number of carbon. And instead of Y over 2, number of hydrogen divided by 2, 6 over 2. So when you break this down, when you add it and factorize and break down, you simply form 2C2H6 plus 7H2O to give you 4CO2 plus 6H2O. So when you simplify this, so that is combustion of hydrocarbon. So with this, I'm sure you've learned a lot under hydrocarbon. Let me know if you enjoyed this class. That is it.